Imagine your best friend has moved, not just to another city but to Mars, a whole new world millions of kilometers away with red deserts and alien skies. You want to share a joke, to hear their laugh, to tell them about your day right now. You want to feel close even though you're separated by an unimaginable distance. So you send a message, but it crawls across millions of kilometers, taking long, lonely minutes to arrive. The silence in between feels endless. By the time your friend laughs, the moment has passed. The connection feels stretched and delayed by the immense distance. It's like trying to have a conversation through a canyon, with echoes that never quite line up. This is the reality of communication today, bound by the laws of physics. No matter how advanced our technology, we can't outrun the speed of light. But what if you could bypass that delay? Imagine holding a special coin and your friend on Mars holds its identical twin. These coins are more than just metal, they're a bridge. The instant you flip your coin to heads, theirs flips to tails, at the exact same moment. No waiting, no lag, just instant connection. It's as if the two coins are still one, sharing a single existence despite the cosmic gulf. The distance between them seems to vanish. This isn't magic. It's a glimpse into the strange reality of the quantum world, where the rules are unlike anything we experience in daily life. It's a whisper across the void that travels faster than any radio wave. A connection that defies our ordinary sense of time and space. This idea of an instantaneous connection has captivated us for centuries. From smoke signals to satellites, we've always dreamed of closing the gap. We yearn to collapse the space that separates us from those we care about. The ache of distance is universal, felt by everyone who's ever missed someone far away. The universe, it turns out, might just have a way to do that, a secret hidden in the fabric of reality itself. It's a phenomenon so bizarre that even Einstein was unsettled by it. He struggled to accept what the equations revealed. He called it spooky action at a distance. The phrase hints at the mystery and wonder behind this effect. This spooky connection is what we now call quantum entanglement. It's a real phenomenon, tested and confirmed in laboratories around the world. Exploring this phenomenon is a journey toward a new frontier in how we connect, with each other and with the cosmos itself. The possibilities are only beginning to unfold. So what is quantum entanglement? It's one of the most fascinating and mysterious phenomena in all of physics, and it challenges our very understanding of reality. Think of the universe as made of tiny particles, electrons, photons, the building blocks of everything. These particles are unimaginably small, yet they make up all matter and energy around us. Sometimes two particles are created together in a special, connected way. They become entangled, meaning their properties are linked no matter how far apart they travel. Imagine you have a pair of gloves, one mailed to the other side of the world. Even before you open the box, you know they're a matching set. Open your box and see a right-handed glove, you instantly know the other is left-handed, no matter where it is. Quantum entanglement is like that, but stranger, much stranger. The entangled particles don't have definite properties until one is measured. They exist in a state of fuzzy potential, a blur of possibilities. Let's say we entangle two photons, the particles of light that make up everything we see. Before we look, neither is definitively up or down. Their states are undefined, existing in a kind of quantum limbo. But the moment we measure one, we know with certainty the state of the other, no matter how far away, even if they're on opposite sides of the universe. It's as if they are communicating, but this breaks all the known rules of classical physics. This baffled Einstein. How could one particle know what happened to its partner instantly, even light years apart? He called it spooky action at a distance. The answer: they're not sending signals or messages in the usual sense. They're two parts of a single quantum system, a single reality that spans the distance no matter how great. Measuring one simply reveals the state of the whole, as if you're uncovering a hidden connection. This concept is a cornerstone of quantum mechanics, tested and proven in countless experiments by scientists around the world. The particles aren't sending secret, faster-than-light messages. They're behaving as one, unified system. This strange, non-local connection is the key to understanding entanglement. It's the secret ingredient that could one day power a new era of communication, computing, and technology beyond our imagination. When you make a phone call or send an email, you're sending information, signals that travel at or near the speed of light. It feels instantaneous, but there's a hidden journey happening every time you connect with someone, whether they're across the street or across the world. That's about 300,000 kilometers per second. the ultimate speed limit for information in our universe. For conversations on Earth, it's almost instant. The delay is so tiny we barely notice it. But the universe is vast, and even light has its limits. Over cosmic distances, those limits become obvious. This cosmic speed limit, set by Einstein's relativity, is why communication lags. No matter how advanced our technology gets, we can't break this rule. Light takes about 1.3 seconds to reach the moon. That's the minimum time for a signal to travel one way. A round-trip conversation? 2.6 seconds of awkward delay. Imagine trying to chat with that pause after every sentence. Now, imagine Mars, over 50 million kilometers away at its closest approach. The distance can be even greater, depending on the planet's positions. A radio signal takes more than 3 minutes to get there and another 3 for a reply. That's a 6-minute lag minimum. Real-time conversation? Impossible. You'd have to wait for every response. This isn't a problem we can solve with better tech or faster computers. It's a fundamental law of the cosmos, woven into the very fabric of reality. Every form of communication today is bound by this speed limit, whether it's a text, a call, or a signal to a distant spacecraft. But quantum entanglement seems to offer a loophole, a strange phenomenon that defies our everyday experience. The information revealed by measuring one entangled particle about its partner doesn't seem to travel at all. It's just there, instantly, no matter how far apart they are. This is the crucial difference between classical and quantum communication. Traditional communication sends a package of information across a distance, always limited by the speed of light. Quantum entanglement suggests a system where the information is already present at both ends, just waiting to be revealed by measurement. It doesn't break the speed limit because nothing is actually traveling faster than light. No signal is sent in the traditional sense. Instead, it sidesteps the problem entirely by using the non-local nature of reality, connecting distant points in a way that seems almost magical. This could revolutionize how we think about connection, opening doors to new forms of communication we can barely imagine today. The challenge is harnessing this phenomenon for practical use, turning quantum weirdness into everyday technology. Scientists are working to turn this quantum quirk into a real-world tool, experimenting in labs around the globe. The future of communication may be stranger and faster than we ever imagined, reshaping how we connect across the cosmos. This isn't just theory anymore. Scientists are building real devices that harness entanglement. China's Messias satellite, launched in 2016, beamed entangled photons to ground stations over 1,200 kilometers apart, proving the spooky connection holds strong. Other teams are building quantum networks using fiber optic cables, linking cities in places like the Netherlands. These experiments are the first sparks of a technological revolution. They're like the early telegraph lines, slow, limited, but proof of concept. The principles are sound, and the engineering challenges, while tough, are not insurmountable. Scientists are actively manipulating entanglement, laying the groundwork for a future of fundamentally different, more secure communication. The quantum revolution has already begun. One of the most powerful applications of quantum communication is security. Today we encrypt data with complex math, but future quantum computers could break these codes. Quantum communication offers security based on the laws of physics, quantum key distribution, or QKD. Two parties exchange entangled photons, creating a shared secret key. If anyone tries to eavesdrop, their interference is instantly detected. The very act of spying reveals the spy. This makes quantum encryption fundamentally unbreakable. The security is guaranteed by nature itself. This could protect everything from national secrets to personal messages. It promises a world where privacy is truly private. Quantum communication is the ultimate secret handshake. The idea of instant, faster-than-light communication is a science fiction dream. Quantum entanglement's instant connection seems to make it possible, but there's a catch. You can't control the outcome of a quantum measurement, it's random. So you can't use entanglement alone to send a chosen message. To actually communicate, you still need a classical, light-speed channel. This limitation is called the no-communication theorem. It preserves causality and prevents paradoxes. So the science fiction Ansible remains a dream. But entanglement still enables perfectly secure keys and even quantum teleportation, transferring quantum states, not messages, across distance. The real-world applications are just as mind-bending as fiction. Even with these limits, the dream of instant connection persists. Entanglement fires our imagination. What if there's a piece of the puzzle we're missing? The allure of an Ansible is about more than convenience. It's about our need for connection. Imagine interstellar exploration. Messages to Proxima Centauri would take years. An instantaneous link would change everything for astronauts and explorers. This dream pushes us to think creatively, to explore the frontiers of quantum physics. The quest for instant communication drives real-world breakthroughs in quantum computing and secure networks. The dream itself is a catalyst, inspiring innovation and discovery. As quantum communication matures, it could reshape our world. It's not just an upgrade, it's a new global nervous system, operating on quantum principles. This network would offer security unimaginable today, protecting data with the laws of nature. It could link quantum computers worldwide, accelerating discovery in medicine, science, and more. Entangled sensors could revolutionize navigation and environmental monitoring. On a human level, quantum-secure calls could foster new digital intimacy and trust. Building this network will require global collaboration and new technology. The journey has already begun. We are at the dawn of a new information age, powered by the quantum realm. We began with a simple desire, to talk to a friend far away without delay. This journey has taken us from the loneliness of space to the interconnected world of quantum particles. Quantum entanglement is not just a curiosity, it's a tool that could transform how we connect. The path forward is challenging, but humanity is driven by such quests. The universe has revealed that reality is more interconnected than we imagined. Now it's up to us to use that knowledge to build bridges, networks that are more secure and trustworthy. The cosmos is alive with possibilities waiting to be discovered. Quantum entanglement is a whisper from the universe, telling us our connections can be stronger than we know. The universe is calling, offering a new way to talk across continents, and maybe one day, across the stars. And we are finally learning how to answer that call.